All right, this is the arithmetic series lesson. In this investigation, we're going to look at the differences between a sequence and a series. So the sequence is basically just the pattern of numbers, 1, 3, 5, 7, 9, or 3, 6, 9, 12, or -10, -5, 0, 5, etc. Where the series is those same sequences of numbers, or patterns of numbers, 1, 3, 5, 7, 9, with addition signs in between. So we are now adding those up. So it's 1 plus 3 plus 5 plus 7 plus 9, or 3 plus 6 plus 9 plus 12 plus what the next number, etc. So in an arithmetic sequence, the difference between consecutive terms is constant, and arithmetic series is going to be the same thing, but it's now the sum of the terms in an arithmetic sequence. So we are adding up all of those terms. An arithmetic sequence, for example, is 1, 3, 5, 7, 9. The related arithmetic series would be 1 plus 3 plus 5 plus 7 plus 9 plus the next number that would come along, which would be 11. If I take a look at this in terms of a formula, I've got S1, so this means the sum of one term is basically just the first term. So the sum of 1 is 1. The sum of the first two terms, then, is term 1 plus term 2. So here's term 1, here's term 2. 1 plus 3 equals 4. So the sum of the first two terms is 4. The sum of the first three terms is term 1 plus term 2 plus term 3, which is then 1 plus 3 plus 5, giving us 9. So the sum of the first three terms is 9. The sum of the first four terms, 1 plus 3 plus 5 plus 7, is 16. And if you had to find the sum of the first five terms, it would be 1 plus 3 plus 5 plus 7 plus 9, which would be 25. So these are what we call finite sums because there's an actual answer. Sometimes we can find these sums using our mental math, and other times we need a formula for them. So just like with the sequences stuff, there was a formula for it. Now we have two formulas for the series. Both are used interchangeably. One is just shorter than the other if you happen to know the last term, Tn. If you don't happen to know the last term and you know D instead, then you can use the second one. So you can use either one at any time typically, depending on what information you've been given. So let's just break these down now. Sn is the sum of the first n terms. T1, like before, is the same as A, which is the value of the first term. N is the number of terms. D is the common difference between the terms. And Tn is the value of the nth term. Sometimes it can be the last term, but often it's just the value of the nth term. Example 1, find the sum of the first 20 terms of this series. So I always write out what I know first. The first term, T1, is 5, so the value of that term is 5. The common difference, so the difference between 5 and -1, and then 1 and -7, is -6. So we're going down, we're subtracting 6. My n is 20 because it's the first 20 terms. So this is my n. Tn is my last term, so I don't know what that is. And my Sn, I also don't know what that is. So I had two formulas to choose from. The formulas were n times T1 plus Tn divided by 2, or the other one was Sn equals n multiplied by 2 times T1 plus D times n minus 1, all divided by 2. And so as you can see, since I don't know Tn right here, I can't use this formula because I don't know this one. So that's telling me I'm going to use this formula instead. So if I plug in those numbers into that second formula there, so the sum of the first 20 terms is equal to 20 times 2 times the first term, which is 5, plus D, which is -6, times n, which is 20, minus 1, all divided by 2. If I plug the stuff in the brackets into my calculator there, I end up with 20 times -104, all divided by 2. And if I plug all that into my calculator, it gives me -1040. So that is the sum of the first 20 terms. Example 2, given the first and last terms, find the sum of the arithmetic series. So again, I start by writing out what I know. The first term is 7.25. The common difference I don't know this time because I cannot tell how many. I could figure it out, but just looking at these numbers doesn't tell me. My n value is 8 from right here. I know my last term is 8, so there are 8 terms there. My Tn value, or my T8 value in this case, happens to be 52.75, and the sum I don't know. So again, I've got those two formulas to choose from. Since I know n, I know T1, and I know Tn, I'm going to use this formula because it's a little bit shorter. If you were to compare it with the other formula, I don't know the value of d here, so I actually can't use this formula without having to calculate d first. Using that first formula, I have S8, so the sum of the first 8 terms is equal to 8 times my term 1, which is 7.25, plus my term n, or term 8, which is 52.75, all divided by 2. When I plug that stuff in the brackets into my calculator, it gives me 60. So 8 times 60 divided by 2 gives me 240. Example 3. Find the sum of the arithmetic series. This typically should be probably written as 2 plus 5 plus 8 plus plus 104, because it is a series. So it probably would not be written with the commas there because that indicates a sequence. So looking at this, this is my term 1, T1, 5 is term 2, 8 is term 3, and then 104 over here is going to be Tn because I don't know what term that is, where it falls in the sequence. So I have term 1 is 2. The value of d is going up by 3 each time. I'm adding 3 each time. The value of n I don't know. Tn is 104. And then Sn, of course, I don't know. So looking at both of those formulas require me to know the value of n. So since I don't know the value of n right here, I need to calculate that first. The only other formula that we know of to use is the one from the sequences. So I'm going to plug in all of these numbers that I can to solve for n in this case. So my Tn value is 104. My first term, T1, is 2. The difference is 3, and I don't know, minus 1. So to solve this, just like we did in the last section, I'm going to minus 2 from both sides. That's going to leave me with 102 equals 3 times n minus 1. I'm going to divide by 3 next. That leaves me with 34, and adding 1 to both sides gives me 35 equals n. So my n value is 35 right here, and now I can use either of these formulas. Since I do know Tn and T1 and n, I'm going to choose to use this formula now because it's a little bit quicker. So when I plug all that stuff in, Sn, now I'm actually trying to find the sum of the first 35 terms, I end up with 35 times term 1 is 2 plus term and Tn is 104, all divided by 2, and that gives me a total of 1,855. Example 4. An arithmetic series has sum of 26, the first 26 terms equaling 290 and 1/3. The difference is 2/3 and term 26, the 26th term, last term in this particular series, is 15 and 1/3. So find the first 3 terms. So the first step here tells me to use the formula to find term 1. In both of our formulas, we need to know term 1. So I'm going to use the formula Sn equals n times T1 plus Tn, all divided by 2. What I'm going to do first here, too, is I'm going to just change these fractions that are mixed fractions now into improper fractions. So I have S26 equals 290 and 1/3. So in order to do that, I just take 290 and I multiply it by 3 on the bottom, and then I add that 1 on the top. And that gives me an answer of, simplified answer of 871 over 3. So that is my improper fraction for that one. And then my term 26, my 26th term is 15 and 1/3. So again, same as top, I just multiply 15 by 3 to get 45 and add 1 to get 46. So 46 over 3. The denominator stays the same. So now I'm going to plug those numbers into my Sn formula here. So my Sn is 871 over 3. My n value is 26, and that comes right from here. So this is my n value, 26. My first term, we don't know, so I'm going to keep calling that T1. Plus my last term is 46 over 3, 46/3, all divided by 2. So in order to solve this equation, I'm just going to multiply by 2 to get rid of the denominator there. Multiply this by 2. That gives me, on the top, 1,742, all divided by 3. That's equal to 26 times T1 plus 46 over 3. And then I want to get rid of this 26 here, so I'm going to divide both sides by 26. I'm going to divide this stuff here by 26. And when I'm dividing fractions, I actually don't divide anything. I multiply by the reciprocal. So I'm going to multiply by 1 over 26, which means I'm basically taking that top number, the numerator, 1,742, dividing it by 26. That does divide nicely, and that gives me 67 over 3, and that equals term 1 plus 46 over 3. And then my last step here is going just to be to minus 46 over 3 from both sides. So 67 minus 46 leaves us with 21. 21 over 3, which reduces to 7. So our term 1 value is 7. So term 1 is 7, term 2, and term 3. In order to get from the next term, from one term to the next term, I'm adding 2/3 because that is my common difference from up at the top. So the next term, term 2, would be 7 and 2/3, and then term 3 would be 8 and 1/3. Last example, number 5. The bottom row in a trapezoid had 114 cans. Each consecutive row had 7 fewer cans than the previous row. There were 12 rows in the trapezoid. How many cans were in the trapezoid? I'm going to start by writing out the pattern of numbers here. So I've got 114 in my first row. The next row, it has 12 fewer cans, or 7 fewer cans, so it leaves me with 107. The third row would have 100, etc. And I want to find the sum of these, so I'm going to write it out as a series. And altogether, there are going to be 12 rows. So this is my term 1, term 2, term 3, and it's going to go all the way up to my term 12, which I don't know what that is. So I'm going to write down what I know. I know term 1 happens to be 114. I know n is 12 because there are 12 rows. I know the difference is going to be -7 because there are 7 fewer cans in every row. My last term, tn or t12, I don't know what that is. And then sn, I also don't know what that is. So because I don't know tn, I'm going to use the longer formula for this one. I'm going to plug in my numbers. So the sum of the first 12 rows equals 12 times 2 times 114 plus -7 times 12 minus 1, all divided by 2. If I plug in all the stuff inside the brackets, inside those square brackets, I end up with 151. And that leaves me with a total of 906 cans in total.